Alrighty, let's get into it. We're going to start with the origins of statistical process control here. A boy, soon to be named Walter, was born on March 18th, 1891. He went on to be successful in school life, obtaining a doctorate in physics in 1917. The next year, he had the job of improving telecommunications at the Western Electric Company, and this is where it all began. The man was brought in for his methods of monitoring manufacturing variables to find relationships between them, and in turn improving quality and production cycles. These ideas came to be known as statistical process control. Much of the time, we must track how our production quality and efficiency changes in relation to its environment. Environmental variables can include anything ranging from the temperature in the rooms where parts are constructed to the different materials used in construction. The point is that there is a near infinite number of variables that affect a product's quality. There's no way you can control all of them, but with SCP you can at least hope to manage some here and there. We oversee production lines and controlled environments to gather data that reflects change in quality, production speed, construction costs, etc. We use control charts to analyze the results from isolating a variable. We clearly illustrate the relationship between the variable and the desired statistic. Cost, damage threshold, construction, whatever you need. This information can then be translated to those without statistical or even engineering knowledge, those that sign off on the purchasing of new equipment and such alike. This is all apparent in the field of computer engineering. We're using varying shapes, materials, and methods to manufacture computer hardware, but there are many combinations of variables that maximize efficiency in different ways. A lot of the time, we must compare materials while constructing motherboard circuit the same way over many trials. And then we would have to control the material while testing different circuitry. There ends up being tons of data to outline the pros and cons of every combination of variables, and it can be an overload to even the most highly capable. Using the methods of statistical process control, we simplify and organize all the data into charts that tell us exactly what we need to know whenever we need it, rather than having to analyze changes at the first level that can affect our production at levels further down its timeline. Statistical process control is about managing the inputs of our system at a controlled rate to break down what goes into manufacturing our product. Without the help of SPC, we would be lost. Now I have to say thank you to Walter A. ShewHart for blessing us with some next-gen statistical analysis. We've gone pretty far with you. Thank you.